I'm back inside my MS6100 frequency counter. Some time ago in part 1, I found out that what appeared to be the base reference, the time base reference, was actually just a focus diverter. It was completely bogus. And I did find that the time base reference is a crystal with a variable capacitor to adjust the frequency. And this is a comparison of the 3 different crystal devices generally available. And here's the temperature versus deviation in frequency. So for a crystal oscillator, the maximum minimum is 20 part per million. The next higher quality is a temperature compensated oscillator. Again, it has frequency variations, same temperature range, but instead of 10, there's 1 part per million. And the next one we have an oven controlled oscillator. There's still some deviation, about 0, but now we're talking about 1 times 10 to the 8th parts per million. I started out with the oscillator having this, and I was unhappy. This is the way it came from the factory. I purchased a temperature compensated oscillator. This little fellow right here. 2 of these TCXOs for $22.50. So $11.25 a piece. I installed one here. I've adjusted it as close as I could to 8 megahertz, which is the desired frequency. And I've hooked my shop reference, which is 10 megahertz. Oh, these wires don't fall off. And can you see that? It reads 10. Adjusting it to 8 megahertz it's very difficult. It's touchy. Very touchy. And let me show you how I did that. I have the input to my oscilloscope, the yellow input, hooked to my shop 10 megahertz reference. The purple input comes from this VFO QRP Labs GPS Discipline VFO. So I'm comparing the frequencies. And let me change the frequency of the oscillator by 1 hertz. See how that went? Take it back to 10 megahertz exactly. A little bit raised at 1 hertz, and see. So that tells me that the little oscillator is capable of being very, very close. Now I'm going to change the oscillator frequency to 8 megahertz. Now this is 8 megahertz from the signal generator. This is the signal for my square wave TCXO. And you see they're pretty close. But with the adjustment being as touchy as it is, that's as close as I can maintain them. Now the nice thing about this modification Well, first of all, it's cheap. More importantly, it can be mounted in the space available and powered from the existing power supply. The increased drain is negligible. Current's very, very small. Here's the little board mounted power. Took off some of these components from the fake oscillator. Coax cable, little piece of coax from here to there. Shop input, and you see it's reading 10. Oops, just went to 10.1. So I'm going to put the lid on, put it on the shelf, leave it on, and check it every couple days to see what it's doing. Before I put the lid on this, I'd like to point out some things. This is the mangled, I removed most of the parts, and the IC socket. This is the mangled oscillator that did nothing. These missing parts are from the original time base, and I've removed them, of course. This is a piece of very thin coax. See my fingers. This is pin 22. The center of the coax goes down into a hole formerly occupied by a crystal Y1. And this was a good place to get ground. I took out VC1, which is a little variable capacitor. Now I'll put the lid back on. I'm using a handheld camera right now. This is 5 or 6 days later after the first part of the video. And you can see that the frequency counter has indicated 1 cycle, sometimes 2. So the time base has varied a tiny bit.